Okay, so sorry about all that. Now we're ready. Here is a problem that we skipped way back when we did 6.4 at first. And the reason we skipped it is because these formulas come from U substitution. And now that we know U substitution, I can show you where they come from. And then this comes back up later today, so it's a good day to do it. Okay, so first of all, let me remind you, or maybe you already remember, but remember that the derivative of arcsine, is 1 over square root of 1 minus x squared. Remember this from way back in the day? And then the derivative of arctangent, like tangent inverse, is 1 over 1 plus x squared. Okay, those will come back up later, but this is important to know right now. Now back to this problem. You'll see that it kind of looks like an arcsine. It kind of looks like this, except this is a 4 instead of a 1. So let me draw you some stuff. You don't have to write this necessarily. This is just like what I wish was in this integral. So an I wish is this. I wish that this integral was this instead of 1 over. I wish that it was that, because you might be saying like, no, Mr. Cordero, don't you mean you wish it was 1 minus x squared? And the answer is yes, but I could turn this into a 1 minus x squared. So what I mean is, look, this has a 4, this has a 4, so I could factor that 4 out of this bottom. And I would end up with this, factor out of 4. And then, now this is a nice thing, because you might remember, like, square root of something times something, that's the same thing as the square root of each factor. So that would turn into 1 over 2 square root of 1 minus x squared. Just taking the square root of 4, and then you can take out this 1/2. And get exactly the arcsine thing. This is the derivative of arcsine, which we agreed on at the beginning. Okay. So that is what I wish. Now it doesn't actually say 4x squared, but I could make it say 4x squared with a U substitution. In fact, all U substitution is an I wish. Like, I wish this x was a U instead of, you know, whatever it is. That's all U substitution is an I wish. So that's what I'll make it do. I'll make this x squared be 4u squared, and then follow the same procedure. Okay. So hopefully that makes sense. Let me get rid of this because I'll need the room. But that is my plan of action. Okay, all right. So like I said, I'm going to make x squared be 4u squared so that I can follow the same procedure that I just showed over here. Okay, so I'm doing a U substitution. It's just kind of weird because I'm saying this is what I want U to be instead of this is what I want x to be, kind of. Okay, so if I want x squared to be 4u squared, then let me find out what u should be, and then I'll find out what du should be, and then we'll follow the same U substitution. Okay, so this is when you should start writing. If you've tuned out, tune back in, because this is the important part. This is what I'm about to do, replace x squared with 4u squared. Okay, now I want to find out, okay, if I want this to be true, then what does u have to be? So let me divide by 4, I get u squared equals 1/4 x squared, and then that means that if I take square root of both sides, then u should be, square root of this would be 1/2 x. Okay, so this is kind of an important thing. Let me highlight it in yellow. Okay, and if u is that, then du, I'll do it over here, yeah, I can. Du, remember, is just the derivative of this, which would be 1/2 dx. All right, but if I'm just trying to replace a dx, that's the only leftover bit of this integral. If I'm just trying to replace dx instead of half of dx, then I can multiply both sides by 2 and get that 2 du is equal to dx. Okay, that's also cool. Okay, if you're sitting there going, why are you doing your substitution? This is why. Watch this. Now this integral becomes, with my strategically picked u, this integral becomes 1 over 4 minus, we said x squared, we want to be 4u squared. Okay, all right, okay. So now we're there, and now we get exactly what I was just describing before, where I can take out a 4, etc. Are you guys good with how I got to here and why? Any like specific questions? Yeah. Oh, you're a beast. Yes, I forgot that. Yeah, the du, remember, is, or sorry, the dx is 2 du. So I need the 2 somewhere. Thank you, good job. Okay. Other questions though? Okay, yeah, good catch. All right, then now I'm just going to follow the same procedure as I was just showing you before. So this will be 2 times, I can factor out a 4 from the bottom of that. 1 over square root of 4 times 1 minus x squared, or u squared, sorry, u squared du. That's a u, by the way. Okay, now the square root of 4 is a 2. So 1 over 2 times square root of 1 minus u squared du. And now we smile because watch this. This is almost exactly what the derivative of arcsine is, except right now we have a 2 out here that we don't want. That's not a problem. I mean, we know how to deal with constant multiples. Usually when there's a constant multiple that I don't want, I can pull it out. So that's what I'll do. I pull out the 1/2, and I get 2 times the 1/2 here. And so 2 times a half will cancel. And I get 1 over square root of 1 minus u squared du. Cool, all right, and now I'm just smiling because this is exactly the derivative of arcsine of u. So the antiderivative of this would be arcsine. Get out of the way. That's arcsine of u plus c. Well, remember we said that u was, here it is, u was 1/2 of x. So this is arcsine of half of x, or x over 2, however you want to write it, plus c. Okay, all right, okay. So that should match what is up here, and indeed it does. Look, antiderivative integral of this is sine inverse of x over x plus c, which is exactly that. Cool. Now let me say this. If you remember this formula right here, then you never have to go through this entire process. But to BH, like I've taught calculus for a little while now, and I never remember this formula, I always just have to go through this process. So if we come across another one of these, I'll probably not remember the formula. I'll probably have to go through this whole process, but you don't have to. If on your test you see something like this, you can just jump straight to the answer and say, I remember the formula.
Don't.
Okay, what else was I going to say, speaking of tests? That today is the last section, meaning we're finishing the unit soon. That's happy news in one way, but in another way it's sad news because that means that there's a test coming up. So we have the test planned for next Friday, the 11th. Okay. But we'll do a lot of review, so don't freak out, and you'll get like a review packet and all that. Okay, so that's the last thing I wanted to do in this section. Let us now go on to the current section, which is 6. Yeah, here it is. Okay. And then, this is, I mean, strap in, because this is super, super hard. This first one in particular is like so hard to explain and very hard to understand. And until you see how it's done, you would have never thought to do this yourself. But once you see it once, then it's like not that bad. You understand why it's done, but getting there is annoying. Anyway, it's asking us to anti-differentiate this, which I don't know any function that has this derivative. So usually that's a good sign that I should simplify or do U substitution or whatever. If we had more time, if I didn't spend all that time setting up the video or doing the previous example, then I'd say, okay, see if you can make progress. But we're short on time, so let me just tell you that it turns out that the way to make progress on this is to do U substitution. And if you had to guess what the U should be, what would you guess? Remember, usually it's weird parentheses or weird denominators. So what would you say? Yeah. Yeah, yeah, it is what you would think. It is the denominator, square root of x minus 1. Okay. But if I let you do some work on this yourself, you would be like, oh no, I must have done this wrong. Because if you choose this as a u, and you take the du, then look what happens. You guys remember the derivative of square root of x? What is it, before I confuse you just by doing it? Okay, nice. Yeah, that should be 1 over 2 x to the negative 1/2, or in this case, it's helpful to write it in this way, 1 over 2 square root of x, and then dx. Okay, and so like I said, if you were doing this yourself, you'd be like, no, I must have done something wrong, because I'm not trying to replace 1 over 2 square root of x anywhere in this integral. But the thing is that since the u itself is like kind of a square root of x, if I were to multiply strategically by u, then I could cancel out this extra square root of x on the bottom. What I mean is, let me show you what you would get if you just said, okay, what if I just replaced my integral with 1 over u, and then ignored everything, ignored the fact that this has extra stuff that you don't want, and you just said 1 over u du. Let me show you what you would get. Let me show you what would happen. If you did this, then really what your integral would be, this integral would be 1 over u, we said, was square root of x minus 1. Du, we said, was this entire thing. 1 over 2 square root of x dx. That is very clearly not what we started off with. So this isn't exactly what we will turn our integral into. But what we can notice is that there's an extra square root of x on the bottom here. So if I can multiply by an extra square root of x, in terms of u, I'll explain what this means in a second, then we could get pretty close to this integral. So what I mean is, let me multiply by another square root of x, but I need to find out what that is in terms of u. Luckily, that's very easy to do. I take this equation and add 1 to both sides. Then I get that u plus 1 is exactly equal to the square root of x. And now you see what I'm saying. Now I'm saying, okay, let me cancel out this extra guy on the bottom by multiplying by square root of x. What that would do on the u side is this. I would get 1 over u times the extra square root of x that I'm going to be multiplying by, which is u plus 1, du. And again, all that does is it gets me 1 over u is this part. U plus 1 is times another square root of x. We just said u plus 1 is square root of x. Times square root of x. And du is 1 over 2 square root of x dx. Okay, so now you can see why we did that. This square root of x will cancel this extra square root of x that did not show up in this one. like I said, if I wasn't doing this with you, you would have never thought to do this like this. The crazy trick, but it does work nicely. I'll also say that this is way harder than 99% of integrals you'll see. Like even on the AP test and everything, this is way harder. All right, very cool. And so now notice what we have is pretty close to the original that we want, except this has an extra 1/2 that I don't see in the original. That's not a problem though, because like that's just a constant multiple. Constant multiples are easy to deal with. If I don't want this extra 1/2 that does not show up here, I could just multiply both sides of this equation by 2. And then that would cancel the 2 that I don't want. So let me get rid of all this extra stuff that I just canceled. It turns out that this right here is exactly equal to this simplified would be this. No longer is there a square root of x, no longer is there an extra 2. So this is exactly equal to the original, which is what I want. Oh, okay, all right, okay. And this is not that hard to take the antiderivative, which is the point of this u substitution. Okay, that was a lot of pretty weird tricks and a lot of math. So did I lose you anywhere? Anything I could explain better? All right. Okay. Well, good work then if you were able to keep up. And even if not, like if you were half able to keep up, then just like go back and study the notes and you'll see why I did that. Or just ask me after class or whatever. Anyway, turns out that this is exactly the integral that I want. This is exactly equal to the original. Okay, so let's continue with this. That would be 2 times, and then let me write 1 over u times u plus 1. Let me just write that as u plus 1 over u. This is all kind of like side work. This is where the real like math starts, or like where we're actually making progress on the problem. Okay. This is not that hard to take the antiderivative of. Look, it's this fraction of something plus something over something. So the natural thing to do here, which you could have guessed, is to split up the fraction. So let me do that. That'll be u over u plus 1 over u. Cool. And then now you can see that that's not hard to do, because that just gives me the 2 in front times the integral of u over u is 1. 1 over u is, just 1 over u, but we know the antiderivative. Nice. All right, and then now the antiderivative of 1 is just u. The antiderivative of 1 over u is actually, let me ask you about that. You guys remember it? Okay. Sweet, good job. Natural log of, remember you need these absolute values. And then plus c. And then we did it. That's it. We just go back to x, but that's it. This is equal to 2 times u, we said was what? Square root of x minus 1. Okay, all right. Okay, so like I said, no way would you have thought of this trick yourself, but now that you've seen it, like now it's in your mind, so you can access it when it's helpful. And usually this will be helpful only if there's some sort of square root of x on the bottom, probably on the bottom of a fraction, and you're doing u substitution. So yeah, the only reason this was helpful is because the derivative of square root of x is 1 over 2 square root of x. So multiplying by some extra u's will cancel out this extra square root of x that you don't want. Okay, So that's one of them. Yeah, question.
So what you did is you said like whenever you particularly plus one du equal to what you be like x version of whatever you do was.
Exactly that.
And then you solve to make it equal. Are you okay?
Yeah, that's exactly right. Yeah. I said, okay, what if I just make 1 over u du? Is that exactly what I want? No, but I could alter it.
Okay.
Okay, other things? All right. Okay, well then let's do this one. This one was the hardest one that you'll see in this whole section probably. Unless you don't remember like completing the square or long division. But if you remember that, then that was the hardest one. Okay. All right, this one was the last one I did with my 5th period, so we can probably stop after this and then finish the rest Monday. Then review Tuesday, Wednesday, and Thursday, and then test Friday. Okay. So this one, I don't know, what would you prefer? Do you want to try and see if you make progress? It's not super hard, but, or would you rather just me show you and then be done quicker? If you tried, you would learn a little bit more. Maybe. So how about this? Well, how about this? Let me show you, because if I just told you, okay, try it, then there's a good chance that nobody would make progress. So let me show you the first step, and then you guys can probably handle it. Okay, so the first step is the natural first step, where I see something plus something over something. So the first step is what you might naturally think, which is to split up the fraction, like this, that's over. Let me actually do one integral and then I'll split. So there's x over this plus 4 over that. Okay. And then that kind of is the hard part because both of those you can handle yourself. Yeah, so I really don't have to say that much more, except that in this case it might be helpful to write it as 2 separate integrals. Remember, if you have function plus function inside of an integral, that's just the same thing as integral of this plus integral of that. So it might be helpful to see it like that. Okay. And then if you see them separately like this, then it's not that, like, you guys can handle this. If this was on yesterday's PowerPoint, you would have figured it out. And this, we just kind of did one very, very, very similar to that. So see if you can make progress on that. I'll, like I said, like a 2-minute timer. I don't expect you to finish in 2 minutes, but see if you can choose the right things to do from there. And then in 2 minutes, I'll go through the whole process.
The same thing.
Exactly. That's exactly why I did that.
4 u times u, x to the 2u. Make everything
You have
u.
X.
This is the right thing. Yeah. Exactly, yeah. Like this one, you should choose a view, and this one, you should choose a different one. Or actually, this one. We just there's an answer to that. Good job, progress. No, like this was all one. Yeah, yeah, yeah. Okay, all right. I do see some people with, oh, and this is up. It didn't make a noise, but okay. Let me stop you wherever you are. If you're making good progress, then you don't have to look up. But if you feel like you're stuck, then here's the process. 2 separate integrals. This one is very similar to the first one we did in like today, and then this one is just a u substitution. Okay. So hopefully you got there. What did you say your u was if you did get to this point? Yeah, that's good. Yeah, you should have made your u this, because then your du is just negative 2x dx, which is not exactly all that's left over. I want to replace x dx, but this is just a constant multiple difference, so if I divide by negative 2, then I get exactly what I want to replace. Okay, so this left integral becomes negative 1/2 before I forget it, and then this becomes something over square root of u, and then the du is exactly the x dx. We get that on the left half. Okay, did I confuse anyone? Everyone is good with this? Okay, cool. Well, that was the hard part. Now, still have a tiny bit of room down here. Now that just becomes negative 1/2 square root of, and then what would be an easier way to try to take this antiderivative? Like, how could I rewrite that? What did you say? Yeah, exactly. Nice. U to the negative 1/2 du. Now it's just u to a power, so let me bring that up here a little bit. Now it's just u to a power, so this becomes negative 1/2 times the antiderivative of u to the negative 1/2 is just this is u to a power. So we follow that same rule. U to the 1 more than this would be positive 1/2. Then divided by 1/2 is the same thing as multiplying by 2. Okay, so there's this integral, and then plus c, but I'll save the plus c for when these are both done. Okay, there's the left one. Oh, actually, let me go back to x's as well. So from there, that would be, let me do 2 things at once. Negative 1/2 times 2 is negative 1, so negative. And then u was 4 minus x squared. Negative 4 minus x squared to the 1/2. And then plus c, but I'll add the plus c later. Okay, so let me highlight this because it's important, but it's not our final answer, because that's only this one. Or, well, this one. Okay, now this one, does this look familiar? Maybe it doesn't look familiar as is, but if you pull out this 4, which is just like 4 times this fraction, if you pull out that 4, then it becomes 4 times square root of 1 over square root of 4 minus x squared dx. It was just 4 times exactly what we did at the beginning of class. Like exactly with the same exact numbers and everything. Remember that? If not, let me scroll up just real fast. Come on. There it is, look. Exactly that. And our answer was arc sine of x over 2 plus c. So let's not go through the whole work again. This is exactly what we need. So our answer for our current problem will be 4 times arc sine of x over 2 plus c. And so, altogether, hopefully if that makes sense, then we will be good. Our final answer will be this highlighted plus 4 times arc sine of whatever. So here is our final answer. We can put a box for it. Negative 4 minus x squared to the 1/2. Plus this integral is, like I just said, plus 4 arc sine of x over 2, and then plus c. And now we smile. Take you guys down. All right. There you go. That's that, and then that's where I ended with fifth period. Okay, so hopefully that makes sense. I have graded your quizzes, so I can pass those back. So, but not everybody's taking it, so let me hold off on passing them back. But you can see your grade if you want. Also, fifth period got an extra point on their quiz because somebody in that class caught the ball on a stick. So if you guys can do that too, you get an extra point. Does anybody want to try to catch a ball on a stick? Or are you just good without an extra point? Let me show you how easy it is.
Is the board telling the truth?
That was not my rule.
Is it a rule though?
No.
Oh, okay.
You can try. Let me show you how easy it is. Let me show you how easy it is. I'll cut this out of the video until I get it on the first try. Let me show you how easy that is.
Wow.
Oh, I don't think so. There we go, just that extra point.
Yeah, go get us that extra point.
Come on, man. This one.
I'm not allowed to.